Hello there, math fans. Dr. Andy Lovelace here. Going to talk about and brag about some of my students from this summer. At the last minute, our department decided to offer several Math 398 topics courses this summer, and they were thinking of it as courses to do research, to explore research. And so Professor Charles Camacho and I decided to throw together more of a different type of research, an opportunity for us to explore ideas that just required calculus. We wanted to offer an opportunity for students that aren't necessarily further along. And we tried some things, and it didn't all work, but I wanted to take a moment to just brag about the students that have gone through this with us. Tomorrow we're going to do some final projects, and this is what they've put together. We didn't give them a lot of guidance. We did a few different things. And so they've been battling along, and I want to congratulate you students on what you've been doing. They did, in the end, we did several little things, but in the end they did a kind of a one-page project exploring something where they use calculus. And I just think calculus is used in so many places, and we're saying that sort of broadly defined. So tomorrow they're each going to do a little 5-minute presentation on what they've talked about. One person did population of salmon in the Ballard Locks, and this is this gallery we put together. One person did how to use Taylor series to study probability. Another did areas of what happens as you rotate and make hyperboloids. And I was surprised the surface area goes down and goes up. It's kind of tied in with minimal surface area. One person did arc length of the clothoid. How do you use clothoids? Are these things called Euler spirals that you see in connecting roller coasters and train tracks. We talked about that earlier this summer. And one thing that was lovely about this was it was a chance for me to revisit projects I made 15 years ago. And because of the way the courses have changed, I don't get to use them at all. So there is something here, this opportunity to kind of explore, and I appreciate these students for doing this with me. Some students studied things in chemistry and biology. One looked at weather maps. One looked at Apollonian circles, this famous problem, and him and I have now done a lot of work on this. One student is studying implicit functions. What even is a function? Why can't we talk about derivatives of implicit functions? Ask some good questions that I would say in a typical course like this you might not get a chance to explore. One explored compound interest, where the number e comes from. One looked at the calculus of the moon's orbits and did some work. One looked at how you cook pasta. So there's such a variety and opportunity to study what you're interested in. And these are small things, and we're at a time when it's easier to do a little bit of research on, small things from your life than ever before. We can tie a little calculus in. It doesn't have to be earth-shattering. I think this is something we could always do. I'm trying to kind of convince our department that let me teach courses like this. And I thank these students for being our first guinea pigs in this format. For my students in this class, like I said, thank you for going through this. I know at times we were very disorganized. We were experimenting. We tried different formats. So thank you for being on this journey with us as we've tried this out. For my students, my assignment here is the end after our little session tomorrow. We'll have some candy and treats and share what we've done. I want you to take a moment and just reflect on the term. This doesn't have to be you don't need to say that this changed your life. That's definitely not true. But what I would like you to do is just reflect on ideas that you've picked up, something that resonated with you, a story, something you'll take with you as you leave this course. Maybe this is a good time, as you think about being a researcher, it's very easy to move on to other things and then lose track of your notes and never be able to come back. So now is a good time to collect your notes, write them up carefully, write down your follow-up thoughts, put your links to other resources in some place. I don't do that very well, but I hope you can be better than me. So sort of build your portfolio. You may never think about this again, or you might, 10 years from now, suddenly be like, oh yeah, what was that again? Have it somewhere that you can easily locate, and before you go, sort of close it up. Where were you at that time? And then the last piece is just give some feedback to Professor Camacho and I. If we teach this course again, which I don't know if we'll get a chance or not, if we do, we'll probably change the structure a little bit, make the beginning more like make students start with our pre-made projects to explore a little bit, then kind of build a little bit. We gave you too much freedom at the beginning, which some of you loved, but I think it would be better if we sort of stepped it through it a little bit. And I do think this would probably work better in an in-person sort of 1 hour a week seminar that was sort of parallel with our calculus courses, whereas the summer it's been hybrid and there's been other things and you've had other distractions. So anyways, I do want to say I thank you for being willing to just talk about your thing for 5 minutes. When I was a student, I would have avoided a class where I had to speak, which is funny because of what I do now. So, I just wanted you to have this opportunity to sort of get to the edge of whatever they want to call it, research or exploration, and realize that there are a lot of questions to be asked. There's plenty of questions that haven't been solved. And I hope that something here resonated with you. And I appreciate you being our first guinea pigs. All right. Thank you again.